Hey guys, this is looking at part 2 of our review, which is based on solving some equations. First up, we've got to solve some square root equations. Our goal here was to really try to get weird stuff by itself and then solve the resulting equation. First off, if I got a square root on both sides, if I square both sides, it gives me 1 minus 6x is equal to x plus 8. If I add 6x to both sides, I get 7x, minus 8 to both sides, I get negative 7. That means x equals negative 1, which means that D is my answer. For number 18, I'm going to add 5 to both sides to get the square root of a is equal to 6. If I square both sides, I get a is equal to 36, which is a. If you weren't sure what to do for either of these, you could definitely just plug the answers in and see which one gives you the right value. For number 19, I'm going to start off by dividing both sides of this by 2. And I get 2 is equal to the square root of x minus 2. When I square both sides, we get 4 is equal to x minus 2. If I add 2 to both sides, I get 6 is equal to x, which is C. For number 20, if I square both sides, we get 16 is equal to b plus 7 minus 7 to both sides, we get 9 is equal to b. For number 21, if I've got 5 times the fourth root of x is 15, I'm going to divide both sides by 5, and I get 3 is equal to the fourth root of x. If I raise both of these to the fourth power, that gives me 81 is equal to x. For number 22, if I raise both of these to the third power, I get 64 is equal to 8 minus 8n. Minus 8 to both sides, we get 56 is equal to negative 8n. Divide by negative 8, we get negative 7 is equal to n. For number 25, I've got to write both of these in terms of the same base. 216 is 6 to the third power, and 36 is 6 to the second power. So that's going to be 6 to the third times n is 3n is equal to 6 to the 2. 3n is equal to 2. That means that n equals 2 over 3. For number 26, I've got to write all these as the same base. And I might know that 4 to the 3 is equal to 64. That's going to give me 4 to the negative 2x. If I'm multiplying, I'm really adding the exponents. Negative 3x plus 2 is equal to 4 to the third. In other words, negative 2x minus 3x plus 2 is equal to 3. I'm going to minus 2 to the other side, and we get 1 over there. On this side, we get minus 5x. X is equal to negative 1 over 5. And once again, if you can't figure out what to do, you can always plug numbers in from the answers to see which one gives you the choice you want. Looking at number 28, I've got to get everything in the same base again. I know that 343 is 7 to the third, 49 is 7 squared, so those are both in a base of 7. This is going to become 7 to the third, a minus 3, times 7 to the second, minus 2a is equal to 7 to the second times a. All right, 3 times a is 3a. 3 times minus 3 is minus 9. 2 times negative 2a is minus 4a, and that's equal to 2a. I end up with 3a on the right side and negative 9 on the left, which means that a is equal to negative 3. Looking at number 31, we notice that things cannot be written in the same base. So all we can do here is convert this to log form. So we got base, exponent, and answer or argument. That means that we're looking at log base 11 of 24 is equal to n plus 5. Getting n by itself, we get log base 11 of 24 minus 5, and we're done. Number 33. Same thing, there's no way I can get these in the same base, so I'm going to write this as base exponent answer log base 8 of 87 is equal to m minus 7. M is equal to log base 8 of 87 and then plus 7. For number 35, we're basically going backwards from what we just did. We've got this in log form. Here's my base, argument, and exponent. And I've got to write this as a exponential. So that's 12, bring the 3 over, minus 3 is equal to x. X is equal to 9. Similarly, number 37, we've got base answer exponent 5 squared is equal to 7m. 25 over 7 is equal to m after you do that out.